All right, let's dive into one of the wildest, most unexpected stories in all of modern astronomy. We're talking about the discovery of the very first planets outside our solar system. And the twist? They were found in a place so bizarre, so violent, that literally nobody thought to even look there.
So let me just ask you this. Picture it. It's the early 1990s. You're an astronomer, and you want to be the first person to find a planet orbiting another star. Where do you even begin to look? You'd probably point your telescope at a star kind of like our own sun, right? I mean, that's the logical place to start. A nice, stable, familiar-looking star seems like the perfect spot to find another solar system. But that is not what happened. Not even close.
The real answer is, well, way cooler. The first exoplanets were found orbiting the dead, spinning corpse of a star that had already exploded. A literal zombie star. So our story takes us about 2,300 light-years away into the constellation Virgo, and at the heart of this whole mystery is this object called PSR B1257+12. And trust me, it's not a star in any way that you or I would recognize. See, PSR B1257+12 is a pulsar. It's the super-dense core left over after a giant star goes supernova. Just try to wrap your head around this. You've got something with more mass than our sun, but it's been crushed down to the size of a city, and it's spinning hundreds of times every single second. Oh, and it's blasting out beams of radiation like a cosmic lighthouse. It is pretty much the last place in the universe you would ever expect to find planets.
So how in the world did astronomers find planets there? Well, it turns out that the crazy, extreme nature of a pulsar is exactly what made this whole discovery possible. It all boiled down to timing. This specific pulsar spins with just mind-boggling precision. It rotates once every 6.2 milliseconds. That is more accurate than an atomic clock. So every time its radiation beams swept past Earth, our radio telescopes would get a pulse. Tick, tick, tick. It was a perfect cosmic clock. But then, back in 1992, two astronomers, Alexander Wolszczan and Dale Frail, they noticed something off. The clock wasn't perfect.
The pulses were arriving just a tiny bit early and then a little bit late, over and over in this complex but repeating pattern. It meant the pulsar itself was actually wobbling back and forth in space. So the big question was, what invisible force out there could possibly be strong enough to physically push and pull on a dead star?
And this right here, this is the aha moment. Take a look at that top panel, panel A. That big wavy line shows the wobble they were seeing in the pulse arrival times. It honestly just looks like a bunch of noise, but it's not. Once the astronomers figured out the gravitational pull of some planets and subtracted that from the data, they were left with the almost perfectly flat line you see in panel C. The noise was the signal. It was the planets.
And there it was. The cause of that wobble was the constant, gentle gravitational tug of not just one, but multiple planets orbiting that dead star. These were the very first extrasolar planets ever confirmed by humanity.
And here they are, the unlikely family. The system has 3 planets. Planet A is super tiny, just a little rock, only 2% of Earth's mass. But planets B and C, whoa, those were absolutely staggering. These were rocky, terrestrial planets bigger than Earth, and at the time, no one had ever proven that planets like that existed anywhere outside of our own solar system.
Just look at planet B. It's what we call a super-Earth, weighing in at more than 4 times the mass of our own planet. And it just zips around that pulsar in only 66 days. And planet C is right behind it, coming in at almost 4 times the mass of Earth, with a 98-day orbit. I mean, to find 2 massive rocky planets in an environment this extreme, it was a total game-changer for astronomy. Now, a discovery this big, this unbelievable, needed some seriously undeniable proof. And that proof finally came more than a decade later, when astronomers managed to see the planets not just pulling on their star, but pulling on each other. It turns out planets B and C are locked in this beautiful, delicate gravitational dance. For every 3 times that planet B orbits the pulsar, planet C completes almost exactly 2 orbits. We call this an orbital resonance. It means they line up over and over again, giving each other a tiny gravitational nudge in a really predictable way. And this is the knockout punch.
By measuring the tiny little changes caused by that gravitational dance, scientists could calculate the true masses of the planets directly. This wasn't just an inference anymore based on the pulsar's wobble. They were actually measuring the planets interacting with each other. This cemented the discovery beyond any possible doubt. It was real. So the implications of this were just profound. This wasn't just some weird little novelty system. It completely tore up and rewrote our understanding of how and, more importantly, where planets can form. I mean, the legacy here is just immense. These were the very first confirmed exoplanets, period. They proved that planets aren't just limited to quiet, calm, sun-like stars. They can actually form in the chaos after a supernova, maybe from the leftover debris of the dead star itself, like a second genesis. This one discovery kicked the door wide open for the thousands upon thousands of exoplanet discoveries that have come since. And that really leaves us with a pretty fascinating final thought, doesn't it? This zombie solar system proved that planet formation is way more tough and resilient than we ever gave it credit for. So if planets can be born there, in one of the most hostile places we can imagine, it just makes you wonder, where else are they hiding?